one here, DE is splitting this triangle proportionally. Tell me the missing side, EC. I'll give you 3 minutes. Howdy. AFFOIQ. Huh, so weird. Okay. All right, let's talk about this. All right, so to do this, again, the easiest way, or at least one way you can do that, is to set up a proportion that relates to the sides of this triangle. They don't give you the proportion, so again, you have to make it up. There are a lot of different ways you can do that. I could do BD over DA equals EC over AE. Right, where I'm kind of doing like left over right, left over right. I could also done like BD over EC and AD over AE, where I did like top over bottom, top over bottom. It doesn't matter how you set it up as long as you're consistent. The way you chose to set it up on the left is the same as the way you chose to set it up on the right. Left over right, left over right. Once you have your setup, you can plug in your numbers. So I get 10 over 6 is equal to EC, which is what I'm trying to find. over 3. What do I do next? Cross multiply. That'll get me 6 times EC is equal to 10 times 3 is 30. Last step to get EC by itself is to get rid of the 6. So instead of multiplying by 6, divide. EC is 5. And if you plug that into your picture, that should make sense, right? If you look, 6 divided by 2 would give me 3, and 10 divided by 2 would give me 5. And that is actually another way I could solve this problem by using the scale factor of how these multiply to each other. And that's how, that's a method we're going to focus on today. Yeah? For this line right here? Zooms. Let me just walk it through it because I'm not sure exactly. It's BD over DA equals EC over AE. And then 10 over 6 equals EC over 3. And then 6 EC equals 30. Divided by 6 EC equals 5. Oh. I see what you're talking about now. That zooms in the way. Like there's nothing on my screen that I can see what you're talking about. Okay, sorry, that's my bad. Okay. Questions on this? All right. So then what we're going to work on today should be another relatively short lecture using scale factors between two polygons and solving problems with proportions, or now with scale factor. Your choice now of methods you can use. So first is little definitions. In order to identify whether or not two polygons are similar, you will use this definition. Two polygons are similar if and only if they have congruent corresponding angles and proportional corresponding sides. So the angles between them have to be congruent, but the sides do not. They don't have to be congruent. They just have to be proportional. If that is true, then we use this notation, the tilde, between the two polygons to indicate that they are similar. Shape. How about shape? So what that means is that similar polygons have to be the same shape, but they don't have to be the same size. They just have to be proportional. So one could be twice as big proportionally, or it could be a quarter as big, right? It could be smaller, which is different than how we have for congruence, right? Congruence had to be the same shape and the same size. Similar just has to be the same shape. It could be the same size, it could not be. So basically what that means is all congruent figures are similar, but not all similar figures are congruent. Because again, they can be different sizes. I'll give you a minute to copy that down, and then we'll move on and start doing some examples. All right, anybody need more time? Okay, let's do an example. So for example, ABCD here is similar to EFGH. Again, note that we have a new notation now. It's this tilde, and it means similar to. Because as you can see, all of the angles between these two quadrilaterals are congruent. And according to this, all of these are proportional. So I could, if I make up some numbers arbitrarily, let's say this was 10, 4, 6, 8. Then these numbers over here would have to be proportional to them. So let's say if the ratio was 2 to 1, then these sides over here would be 5, 2, 4, 3, right? Where each side over here is twice as big as the side over there. They have that proportion between them of 2 to 1. That makes sense? Any questions about that? How that works? That proportion, too, is the scale factor between these two triangles. Or you could think like a half is the scale factor. So this would be the scale factor if I was taking EFGH to ABCD, right? If I was making this polygon into this one, I would multiply all the sides by 2. And then this would be the reverse. This would be ABCD to EFGH. Be dividing each of these by 2. Right, so I'll give you another minute or so to copy this down before we move on to the next slide. All right, good to go on? Last call? Okay, so then let's do an example. All right, let's have you try one, I believe it's actually what's coming up. So for this, tell me, are these two polygons similar to each other? If so, explain why you think they are. And if not, explain why not. I'll give you 3 minutes. All right, looks like we agree. Are these two polygons similar? Yes, yes, they are. Note that all of their angles are congruent, right? Also note that all of the sides are proportional. If you took 15 divided by 10, that gets you 1.5, which is the same for all the rest of the sides. 6 over 4 is 1.5, 9 over 6 is 1.5, 12 over 8 is 1.5. So 1.5 would be the scale factor if you are going to convert this smaller polygon into the larger one. Okay? All right, so if the last thing we're going to do today is then use that to start solving some problems. Again, you can use this scale factor or proportionally. In your notes for subpoint C, you should write down that if two polygons are similar, then that means two things. The ratio of the lengths of their corresponding sides is the scale factor. And this is just a helpful little piece, tip or advice. That means that the ratio of their perimeters is the same, is equal to the ratio of their sides or their lengths. And that's something that they'll ask you about on the ACT. They'll be like, you don't have to write down this bottom part, but they'll be like, here's a triangle and here's a smaller triangle. The first triangle has a perimeter of 18 feet and a ratio of 3:1 with the smaller one. What's the smaller one's perimeter, right? So that perimeter would also abide by that same ratio, since we know all of the sides follow that, and the perimeter is just adding up those sides. So it has to follow it too. So again, I'll give you a little bit of time to copy down these two results, and then we'll do some practice problems, and then that'll be it. All right, good. Anybody need more time? A little bit? right, how about now? Cool. Okay. Do. All right, so for example, given that these two trapezoids are similar, find the value of z and the scale factor. These are the type of problems that you should expect to be able to do on the homework. So to do this, I can set up a proportion. Since they are similar, I know their sides are proportional. And again, you can set up this proportion in many different ways. You just have to be consistent. So I'm going to do JK over KL is equal to QP over QR. How I decided to set this up was top over side, top over side. Again, another way I could set this up is I could have set this up as JK over QP equals KL over QR, where I did the left top over the right top, left top over right top, and then left side over right side, left side over right side. So again, as long as I'm going like left to right, or top to side, and I'm being consistent in how I set it up, it really doesn't matter how you do it. Once you have it set up, you should plug in your numbers. JK is 10. KL is 15. QP is Z. And QR is 6. And now this is just like all the other problems you've been doing. If I want to solve this, I'm going to cross multiply and divide. So I'll get 15Z is equal to 10 times 6 is 60. I need to get rid of the 15, so I'm going to go ahead and divide both sides by 15. Which gives me Z is 4. All right, so that finds us the value of Z. We also need to find the scale factor. For our class, unless it specifies, we're always going to assume that the scale factor is what takes the smaller one to the bigger one. Okay, so to find that, the scale factor, all I'm going to do is divide the bigger side by the smaller side. That says 15 over 6. Now 6 doesn't go into 15, so if I reduce it though, what? I can divide both of them by 3. So to get my scale factor in lowest terms, you get 5 over 2. Or if you would have told me it's 2.5, that's fine too. This is your scale factor. If I take the smaller trapezoid and I multiply each of its sides by 2.5, it'll produce the larger trapezoid. And again, I could have done this in reverse order. I could have found the scale factor first and then wrote that Z times 2.5 would give me 10. Does everyone see how I got that? This smaller side Z multiplied by the scale factor, 2.5, is supposed to give me 10. And then I could just solve this equation to find out what Z is. And you get the same thing. 10 divided by 2.5 is 4. So again, I did this proportion and then found the scale factor, but you could have done that in reverse and still been able to get the answer to this problem. Questions over the example, or does anybody need more time to write? Okay, last melon. I got 2 problems here that I'd like you to do. This poster, Trip to the Liberty Bell, has been shrunk to this size. It's a 3.5 by 5. The original had a length of 16. Tell me what the width is. And again, this was shrunk proportionally. For this bottom, I have this pool that's a 32 by 16. I have set up a proportional patio that goes around the pool that's a 48 by 24. Tell me, what is the scale factor I used to make the dimensions of this patio? I'll give you 3 minutes. Then we'll go over it. And then the rest of the hour you'll have to work. Okay, got about a minute left. If you have nothing on your paper, I'm going to walk by right now. Stop me and ask for help. Okay. Set up your proportions. So 3.5 over 5 equals what? Okay. All right. Yep. And then, so you did length over width. Okay. Yeah. Okay. So first, you want to set up a fraction over fraction. So you do like 3.5 over 5. That would be the same as over x. Exactly. And then cross multiply. All right. So, if you, then this, on the opposite side would be, what's it? Okay. Set up your fraction. So like this, you can say 3.5 over 5. Then to match, the other fraction would be 16 over x. And then cross multiply. Okay? Oh, golly. All right, so that's a good thing we're going over this, I think. I think we got some struggling. And to be honest, that's a fair if you struggled with getting started on these, because they require you to write your own equation, right? I think we've shown that if I give you the equation, you can solve it pretty quickly. But writing your own equation is just its own skill that you just got to practice, practice, practice. So it doesn't really matter how you start. You just want to start writing, and then I think you'll be able to figure out how to finish it once you do so. So I'm just arbitrarily going to pick. I'm going to do 3.5 over 5. I'm going to do the length over the width as one of my fractions. So just arbitrarily, I'm picking two numbers. That's what they're going to be. And then I need to write the other two to match. That's the key part. So if I did length over width for my first one, then I have to do 16 over x for my second one, so that it matches length over width, length over width. You could have done width over length. You could have these flipped right now, and you would be perfectly okay. You could have done 3.5 over 16, length over length, and then compared 5 over x, width over width. That would be cool too. You just got to pick a method, write it down, because once you have it written down, I think you can finish this out. Cross multiply. 3.5x is equal to, what's 16 times 5? Is that 80? Divide by 3.5, which means x is 22.9. All right, and then for scale factor, all you have to do is remember you pick one pair of sides and you do the bigger number divided by the smaller number. That's it. So I'm going to pick the smaller pair of numbers just because I think they'd be easier to work with. So the scale factor, which by the way, if you want the scale factor, you can represent with the letter R instead of writing out the whole phrase, but you can also just write out the whole phrase, is 24 over 16. Again, I wouldn't leave my answer like this because it is reducible. I can divide both of these by 8. So answers I would accept would be 3 over 2. That'd be great. If you change it to a decimal and tell me that's 1.5, that's fine too. I'm not going to be upset about that. All right, questions about this? Okay. Does anyone want a paper copy? Oh, no. I didn't grab them. Does anyone want a paper copy? Okay, let me go grab those. Print it in. Oh, sweet. Yeah, I'll put them in. All righty. Have a good one, everybody. I'll see you, Tuesday, I guess. Yeah. Bye. See you Tuesday.